For this project, we did all of our code using Python under PyCharm IDE. We used these four Python libraries: matplotlib, plotly, numpy, the BFS algorithm, and the A* algorithm. We put them into Python and then into the Jupyter Notebook. The following is a demo of our project on Jupyter Notebook.
As a part of the upcoming Artemis mission, NASA released a large satellite dataset of the lunar South Pole, which was around the area of the landing site and the exploration site near the Shackleton crater. We wanted to develop an algorithm that will automatically find and map the shortest possible path between two coordinates given the slope, and in which the rover can overcome. So we first tried to understand the large lunar data file, which was 1.5 million lines of latitude, longitude, slope, and height data between a specific range. The problem was that the file was too big to plot, it wasn't sequential, and it wasn't equally spaced. And here is an example of us converting from spherical to Cartesian coordinates. And here are the values. So our first step was to create a sequential, equally spaced, and reduced matrix file that we could have used for plotting and the BSF or A* algorithm. And what we did is that we used the original 1.5 million point data file and we split it into two files. The first one was a 300 by 300 spherical zoom matrix, which we ran the BSF and A* algorithm on, and the other one was the 300 by 300 Cartesian matrix, which we plotted for 2D and 3D terrain. And here are some comparisons of some graphs. The first one is the original, and the second one is the 300 by 300 Cartesian matrix. And you can see it has less points, but it's still a very good representation of the path. And the next one is the original lunar data file, and we just cut off only the rover path, and we did it on spherical, and that's what we got.
This is the rover wayfinding using the BFS and the A* algorithm. We started with a 300 by 300 spherical zoom matrix, which in total consisted of 90k points, and then we created go and no-go cells. So let's say that the rover slope was 15. Slopes that were under or equal to 15 would be go cells, and slopes above 15 would be no-go cells. Then we ran that through the BFS or the BFS and the A* algorithm, and those would traverse through the maze, and it would generate rover path indexes, which we would then convert to path indexes. We would convert those path indexes to latitude and longitudes using the 300 by 300 spherical zoom dataset. And then lastly, we would generate the rover path file. So this is an example of the breadth first search algorithm, and this is an example of the A* algorithm. The breadth first search algorithm creates nodes and traverses all of the paths simultaneously, and it will find the shortest path among all the paths. And the A* algorithm is a directional algorithm that always moves towards the target. And usually A* is faster, but it does depend on the maze. And this is an example of a rover path with a slope of 15. So these blue cells over here, these blue dots, are places that the rover can't go because their slope's above 15, and then these yellow spots are slopes below 15, so these are places that the rover can go through. And the rover does make it from the landing point to the destination point successfully. Now we can compare two different rover slopes. So we can start with 14 and 15. And the 14 slope one doesn't make it all the way through because there aren't enough go cells or yellow cells, and it gets stuck over here. But the 15 slope one is able to make it all the way through because there are enough yellow cells to let it go all the way to the destination point. And now we can compare 14 and 20, and as you can see, with a slope of 20, the path is almost a relatively straight line because there are enough go cells for it to go through, and it has less obstacles than the 15 slope one or the 14 slope one.
So to create our graphs, we used the rover path file from the BSF and A-star algorithm maze and superimposed it on the 300 by 300 Cartesian matrix of the South Pole. And we created two different graphs out of that. One was the 2D, which we did on Matplotlib, and the other one was the 3D interactive, which we did on Plotly. And here's the 3D interactive. Over here is the Shackleton crater, right here. And over here is the landing site, and it goes all the way to the destination site, which is right by the Shackleton crater.